All right, so let's solve a problem because we love doing that. Um, One cube-shaped container has an edge length 2 centimeters longer than the edge length of a second cube. So if we look at this picture, we can see we have a smaller cube down here. This larger cube is going to have each edge is going to be 2 centimeters longer than the smaller cube. The volume of the larger cube is 729 cubic centimeters or centimeters cubed. So we've got the volume of the large cube. When the larger cube empties into the smaller cube, how much water will spill? So a larger cube will have a larger volume than the smaller cube. So it makes sense that if this empties into this bottom one, once this fills, there's still water left over in the large cube that's going to spill over from the small cube. So here's what we're going to do. We are going to work with our volume formula for cubes, but first we're going to define our variable x. We're going to let x equal the side length of the small cube. So what that allows us to do is identify what the volume of the small cube is. Volume is equal to length times width times height. And if all three of those, because it's a cube, all three of those sides will be the same. So x times x times x gives us x to the third power. Now, the large cube has a volume where it's not going to be x to the third power because each side is longer than x. They actually said it's 2 centimeters longer. So we can say that the side length of the large cube is x plus 2. So each side has a length of x plus 2. And then if we raise that to the third power, that's how we have our volume of the large cube. Now, they told us that the volume of the large cube is 729. So let's plug in 729 for the volume of the large cube is equal to x plus 2 to the third power. And let's solve this equation. So if we have to, we know we want to get x alone. We're adding a 2, but this is locked in with this exponent raised to the third power. So what's the opposite of raising to the third power, or what will undo that? Let's raise this whole thing to the 1/3 power. Same thing over here, raise that to the 1/3 power. So on the right side of our equation, oops, there we go. We end up with x plus 2 raised to the 3/3 power, which is just x plus 2. And then 729 raised to the 1/3 power is 9. That allows us to solve for x. We're going to subtract 2 from both sides, and we get a side length of 7. Well, we get x equals to 7. So remember, what does x represent? X represents the side length of the smaller cube. So now we can find the volume of the small cube. So we know that x is a 7, so the volume is equal to 7 to the third power, which is 343. Now, we've got the volume of the large cube is 729. It's emptying into the small cube, which we now know has a volume of 343, so clearly it's not going to hold all that water. So once it fills up, how much water spills out? Well, that's just finding the difference. We're going to take the volume of the large cube and subtract the volume of the small cube. The volume of the large cube, we were told, was 729. We're going to subtract the volume of the small cube, which we just figured out was 343. And that difference is 386 centimeters cubed. So when the larger cube, back to the question, when the larger cube empties into the smaller cube, how much water will spill? 386 centimeters cubed of water will spill.